All right, everyone, welcome to the live. We're going to go over some welding settings, some material prep, and go through some of the basic settings so that when you're doing your fab work at home, you're getting the most out of it. And hopefully here in a few minutes, people will start joining, but we'll see. But the goal of this is so that when you're doing some fab work at home, you're actually getting good welds out of it and build the best product you can and at the safest way that you can. All right. So first things first. So let's talk about material prep. So just about every material out there has some kind of film on it, whether it's mill scale or if it's hot roll, have some kind of mill scale or something. If it's cold roll, have some kind of like pickling, but it's still a scale on it. And aluminum has an oxide on, but we're not going to be covering aluminum. So what do you do with that? So it eats up a tremendous amount of energy when you're trying to weld, if you're trying to weld through the mill scale. And if you're running on the low end of your settings, you'll have a weld that potentially has no fusion at all, which actually which will make it, if you're making trailers or bumpers, or God forbid you're welding a trailer hitch on, basically there'll be no strength there or anything. The weld material might be strong, but there'll be no base fusion. And that's really what you're looking for. We're not going to cut and slice and do any kind of testing, but this is just going to be a high level test, if you will, and show you how to dial in your weld settings as you go. So one of the first things I want to do is I want to lay down a bead, and we're going to take a piece of this. It's just 1/2 inch, and it's still got this heavy mill scale on it from the factory that you'd be surprised how hard it is to burn through that. So what we're going to do is we're going to just take a piece, we're going to weld it to it, and then let's see how well it sticks. So I'm going to and as always, hair is getting to be more and more valuable. So we're going to put our hair cap on, and this is probably one of the better things I have found since I started welding is my readers. And if you go get a pair, get the blue blockers. Be surprised how much clearer it is with the blue blockers versus a regular. I stumbled upon this one, and it works really, really well. And typically I'd be wearing a respirator, but it's kind of hard to talk and use a respirator. So we're going to use one of our little magnets here just to, I'm not going to worry about the actual angle or anything like that. All right. Always do a little quick test just to make sure I can get the motion. Let me scoot this closer to the edge. You don't just waste material. Now, keep in mind, I know while I'm laying this down, it's not a good weld. The whole point of it is just to show that if you're not watching your settings or your penetration when you're welding on, you can actually get a really poor weld that will break out in the field. You can see that, along the toes here, it didn't wet in at all. It's pretty much just like icing. Now on the top area, I dwelled a little bit more. So it's got some penetration, but not much. But at the toes on the bottom one, it's a hot mess. And the other byproduct of this is if you get any kind of pressure on it, it doesn't take much. Yes, it was on there, but it wasn't on there. And I turn it way down. I'm on the extreme low ends of the settings. This is a 220 Miller running on 220 volt. And the whole point of this is more just trying to show that just because you have a bead doesn't necessarily mean that you have penetration. Now, it's not just a trick. I have done this a couple other times. But you can see here, I didn't even get through the mill scale. Now, there are other processes, dual shield and things like that, that will chew you through that mill scale. But most people are running a short circuit MIG at home. And in some cases are not even running a 220 machine or running a 110. So you get considerably less amperage going through it. All right, so with that said, what do you do with that? Well, there's multiple ways to get rid of that mill scale. Let's deal with that first before we get into settings. So to get rid of that mill scale, there's several things we can do. You got several options out there. You got flap wheels you can actually get, right? We have several of them. We are sponsored by Rock Mount. So we have several different types of flap wheels that we get. And these are really good. The stripping disc, and I'll leave all this stuff in the descriptions. These stripping discs really do a really good job of taking off that outer layer without digging into the actual steel itself, because you can't just go at it with a flap wheel always and cause divots in it. And then there's always these abrasive brushes that go on an angle grinder. And with all of these, please make sure you're wearing some kind of eye protection and something on your hands too. And be careful with these, because when these go, these things get that big around when they're spinning. They'll grab you in a heartbeat. There's also other ways to get it off. So we keep a vat of, turn this up here a little bit. We keep a vat of vinegar here that you can just let stuff soak. So you can see it pretty much gets you down to bright metal. It doesn't take much to scuff this up. You can see where it's chewed through just about everything on that mill scale. Now you should still go through it with a Scotch-Brite pad, or something, and just finish up getting it down to bright metal, because that's your end goal at all times, bright metal. Now that was in there for almost 2 days. That mill scale on that 1/2 inch is quite thick. Then you have just standard bar sock went in last night, and you can see where it's starting to chew through it. So when I make things, I'll leave it in there for a day or two. Now you do get to the point to where if you leave it in there too long, it will start corroding the material. You'll start getting big pits and stuff in it. So be careful with that. And if you're welding aluminum, which once again, we're not going to cover, a standard wire brush, and try to buy stainless steel brushes so you're not brushing in, iron from the steel bristle. Brush one direction, get through that outer crust, Because once again, even on aluminum, you'd be surprised how much energy it takes to pop through that. You get like this hard candy coating that's, by the time you get through it, all the base metal is liquefied. So wire brushes, and even on your other tubing, if you're building trailers and stuff like that, even this pickle finish, you want to get through that just to maximize the amount of penetration that you can get with your weld. And a big vat of vinegar does a really nice job. Now, if you're welding up a trailer or something like that, obviously you're not going to dip this whole thing in vinegar. So stuff like these scuffing pads or these flap wheels, they work great for that. You get to choose how much you lean on it to go through. So let's talk about your settings real quick. So on that setting, I'm just going to read it right off the machine. I was running 15 volts at 200 on my wire feed. Now I'm running 035 wire. And this is right off Rockmount's website. I'm running this Rockmount Polaris. You know, it tells you want to be between 15 and 29 on the voltage. Well, I'm on the absolute low end of that. And it gives you your amperage, and it gives you your gas flow. The gas flow I run around 30 because gas is fairly cheap. I don't have to worry about any kind of porosity in the weld pool at all. But you have what's called burn off rate. Now on Miller's website, they do a really good job of going down wire burn off. And they give you a nice little chart. I've kind of cheated. I love my whiteboard. So what they've done, and I'll put all this in the description. So what it says here is that for every 1 amp for every thousandths of material thickness. So you can take a caliper or something and measure your thickness of material. Right? So the wire has to burn off so much to be able to get your amount of deposition of your wire into the weld. And then they break it down, 3.5 inches per amp for 023. And 035 is what we're running, is 1.6. And it's just a simple calculation. Most of your wire machines, you don't set raw amperage, but you need to know what that is to go through to calculate your wire feed. So 035 wire, it's 1.6. For 3/16 material, says I should be running around 299 inches per minute on my wire. So inches per minute, feet per minute. Yeah. So I'm running right now 199, not 299, right? So I'm going to say 300. And your gas, the gas, and we covered, I run around 30. And then the voltage range for my wire between 15 and 29. I'll typically run it around 20, 25. You'll have to figure out where you're at with your wire you're running and what kind of welder you're running. Because a 110 welder is not going to run the same on thicker stuff as it will on 220. And it could be a case where if you're trying to weld 1/4 inch material with a 110 welder, you're not really getting much penetration. So that's something you're really gonna have to be cognizant of when you're welding with it, to make sure that you're getting the full penetration that you need. So if I go through and I set the welder up at those settings, and obviously you can't see, but if I dial it in around 22 at that 300 mark, if we lay down another bead, we should get a lot different weld. Now I'm going to take this down to bright metal real fast. Tell you what, it's cooled off. Let's take this one down. I'm going to take off that. I just took off a strip of that mill finish. And I'm just going to take the other side of the, so I didn't show you this side. This is that one I broke. You can see it was just laying on top of the mill finish. So if I take this, and we're just going to weld right in that area. So I just set up that T-joint so that we're going to weld in that area. It's going to be a lot different weld. It was like, I never liked to, so after you weld, you always get this little BB on the end. I don't like redepositing that in the melt, in the melt pool. It's a lot different when you're doing this live. You're trying to remember every exact word because you just know you're getting called out on every one of them if you say anything wrong, which I'm sure that I have. So let's lay this down real quick. Now, before you would go and do any kind of welding on any projects, always run a test piece or two or a dozen, however many it takes. And just to make sure that you're running what you would consider a good, safe weld. So I should be able to take this now, pull that off. I should not be able to, just with that wrench, pull that off of there. You know, it's wanting to move, but I'm actually in, I've got penetration. So I've got penetration on the toes on both the base. I'm trying to do this and look at the camera to see. The toes are all wet in fairly well. So I've got some penetration. Now, if we were to cut this, and I use just like a basic, like a cursive E as I go. And I'm pushing it. And if you guys remember the flux core, if I was running flux, I'd be pulling it. So just making that little E. And once again, I'm running that Polaris MIG. But the technique of welding and cleaning your material, that's a universal thing. You have to make sure that your material's clean. Just remember the statement, bright metal. Because if you're running, let's say you're running 2-inch angle, especially if you're running a 110 welder, trying to get through that mill scale, you're losing a lot of penetration. And if you're pulling a trailer or putting weight on it, you're not doing yourself a good service. And potentially you set yourself up for, I'm going to say lawsuits and everything else, get out on the highway and it pops. So make sure that you clean everything. And fortunately, I don't have any questions coming in right now. So, but you know, that's how it works sometimes on a live. People are busy. Vinegar once again does a great job of cleaning. I'll leave a list of everything in the descriptions, but make sure if you're switching between flux core and hardwire with gas, make sure you change that polarity because it's drastically different. Remember, wire with gas is a DC EP electropositive, and your flux core DCEN electronegative. It makes a difference on which way the current's flowing. So in negative, it's going from the gun to the work. The positive, it's going the other direction. You're trying to burn the wire. So that's what we have today. I'll leave all this stuff in the descriptions. I'll leave a link to this stuff from Miller as well. It's a really good description on wire burn off. And I'll also leave a link for the rock mount wire and flap wheels, everything that I use. Once again, we are rock mount. We are sponsored by Rock Mount, and I wouldn't be using it if it wasn't good stuff. So I hope that you at least trust me from the standpoint of I'm not trying to push junk, right? So their whole thing with their materials are primarily maintenance and repair, so you can use it in the field a little better, and it makes a much stronger weld and fixes your stuff right the first time. So that's the whole reason why I like the Rock Mount products. But I know a lot of you guys are going to go out to Harbor Freight or to Lowe's and get the 110 units, or you know the MIG or the flux core units like at Harbor Freight. Just follow basic good welding practices. Getting tongue tied here. Get down to bright metal, no matter what it takes. Don't lay your beads on top of the mill scale, and you'll get a better weld for it. And remember, this country needs more people out in the trades doing things with their hands. Need good quality welds, good quality whatever you're doing. Try to do your best, and always remember to do better the next time. So I appreciate you joining the live, and hope you got something out of this. Please leave me some descriptions, and remember, we're trying to grow the channel this year, so I'd appreciate you subscribing. Thank you.